As we are winding down the semester, one of the last things we're going to be looking at is how to use quadratic equations in word problems. We need to do a little reviewing. Perhaps you have heard of the phrase consecutive integers. That just means numbers that are next to each other on the number line. They can be negative, they can be positive, but there's no fractions or decimals. Two consecutive integers are represented by variables like x and x plus 1. Now if you think about it, consecutive integers are like 3, 4, 5. So if this first one was x, you would add 1 to get the next one. You'd add another one to get there. Then we have consecutive odd integers. And a lot of students have trouble with this because they don't want to add that x plus 2. Well, let's just see why that works. If we have 3, 5, 7, which are definitely odd integers, and this one is x, can you see how you need to add 2 to get to 5? That also works with our even integers. You set them up the same way. Look at this. You have 2, 4, 6. So if the first number is x, you again would have to add 2 to get to 4. You would have to add 2 to get to 6. So even though we have odd and even, they're set up the same way. It's just your starting point is different, but they're still spaced out every 2 on the number line. And then you're going to see the word reciprocal, and of course you should know that you're going to flip it over. So if you have a number x over 1, then its reciprocal will be 1 over x. But let's see how we're going to see these words and set up quadratic equations. Now remember, that involves an x squared. Sometimes we might need to factor, and we might need to use the quadratic formula. Alright, so just like throughout the semester, I've asked you to define your variable, write your equation, and solve. You cannot just give me the answer, even though on some of them you might be able to just figure it out. And that's good, and that way you'll know if you have the right answer. So we want to find two consecutive positive integers whose product is 132. Alright, so positive means our answers cannot be negative. Let's get this, two consecutive integers, so two numbers in a row. So I'm going to let my first integer be x and my second integer be x plus 1. It did not say even or odd, it just said consecutive integers, so that's why I want that plus 1. And then it says whose product. That means to multiply. So I want to multiply x and x plus 1. And of course is means equals 132. So we have defined our variable, we've written an equation, now I need to solve. So I'm going to go ahead and multiply that out. And since it's a quadratic, I need to set it equal to 0. So let's subtract 132. I believe this factors. And 11 times 12 is 132. Make that one positive and that one negative. That gives me positive 1 in the middle. And then of course set each factor equal to 0. And solve. But you are not finished yet. We need to find two consecutive positive integers. Well, first of all, is negative 12 positive? No, it's not, so we're just going to throw that out. But x equals to 11, that's still not two consecutive positive integers. That's why I want you to do the part where you define your variable, because that's what you want to find. You want to find x, but what else am I asking you to find? X plus 1. So I need to know what is x plus 1. Well, if x is 11, what's 11 plus 1? 12. So my two consecutive positive integers are 11, 12. Pretty easy. Let's look at another one. Let's look at the second example. Again, you're going to be able to know what the answer is without doing the algebra, but we're going to just go through the algebraic process so when you can't figure out the answer, you'll have a tool to get the answer. Right, so we want to find two consecutive odd integers. So we want the first one to be x, and that second one, look at your notes, odd, is going to be x plus 2. And again, whose product, that means to multiply. So I'm going to take x and x plus 2 and multiply them together. That means equals, and then we have 35. So again, I'm going to multiply this out. It's a quadratic, that x squared and x, so I'm going to set it equal to 0, and I believe this factors. And of course you're going, well, yeah, it's 7 and 5. I know. And then we're going to set those both equal to 0. And if you stop there, you've just lost an easy point because you have not found two consecutive odd integers. Again, we want to go back up to that step. So I have x, but wait a minute, I have two different x's. That's right. Now I need to find x plus 2. So how do I do that? Well, I'm going to just put x plus 2 right underneath here. Okay, so if x is -7, -7 plus 2 is -5. But what if x is 5? 5 plus 2 is 7. On the last problem it said only positive numbers. This time it didn't say that. So I have found two sets. I have -7 and -5. Those are two consecutive odd integers, and if I multiply them together I get 35. But I also have 5 and 7. Those are the positive ones, and if I multiply 5 times 7, I get 35. So sometimes you can have different sets of answers. And again, this is why I want you to define those variables so you know you've got to find just x and x plus 2, or whatever else they've asked you to find. Alright, going to get a little bit harder. So we have the sum of the squares of two even consecutive integers. Wow. Okay, so let's get it down to find the integers. So I'm looking for two consecutive even integers. So again, my first one, always let that be x. And my second one, if you see even or odd, that's going to be x plus 2. But this time it doesn't say whose product. It says these words. The sum, well, that means to add. The squares, well, squaring means I need to square something. Alright, so if I have x, that's my first number, I need to square it. I need to add, because it says sum of this number squared. So that's the sum of the squares of two consecutive even integers. Hopefully you see that. Let's see that one more time. The sum, we're adding, the squares of two consecutive even integers. Now we get to the is part, which is equal 340. Find the integers. So this is going to take a little bit more work. So we have x squared plus, and remember when we see something squared we either want to write it out twice on our paper or in our brain, and you FOIL that out, you're always going to get a trinomial. I need to collect like terms. And I'm going to subtract 340 from both sides. So that's going to be a -336. Wow, that's big. But I do notice that they're all even. So let's factor out a 2. So let's see, 2 goes into 336. 168. Well, that trinomial should factor. This is where it's a little bit harder because 168 is kind of up there. You're thinking that's not really on my multiplication tables. Well, I know that 12 times 12 is 144. So it needs to be a little bit bigger and they need to be even. So what about 12 times 14? That's 168. So let's try a positive 14 because I need a positive 2 and a negative 12. Now, remember, since that 2 factor does not have an x in it, that's not going to be part of my answer. I just need the factors with my variables. So I get x equals -14 and x is equal to 12. Am I done? Of course not, because I've only found my x's, and again I'm going to have different sets. Now I need to find my x plus 2's. Okay, so just write it right underneath here. Say, alright, if x is -14 plus 2, -14 plus 2 is -12. And again, 12 plus 2 is 14. And yes, they usually are the same numbers, opposite in sign, but not all the time, so you need to be careful. Okay, so now we have not consecutive, we've got a sum of a number and its reciprocal. That sounds pretty easy. The sum of a number. What is the number? Well, I'm going to let the number equal to x. And its reciprocal, what's its reciprocal? Remember, is 1 over x. What am I going to do with it? The sum means I need to add the number, which is x, and its reciprocal, which is 1 over x. Then I get to the is part, which is equal 6. Well, that's an interesting looking equation. That's called a rational equation, which we've studied in previous lessons. So let's get rid of the fractions by multiplying by the LCD. Remember, the LCD in this case is going to be x. So I need to multiply every term by x. And I'm doing that to get rid of the fractions. Right, so here nothing cancels. I just multiply those together and I get x squared. But here the x's cancels, but I still have that 1 equals to 6x. That's a quadratic. I'm going to move this over here and put it in standard form. But wait a minute, that doesn't factor. That means also use the quadratic formula. So this is a great chance to practice our quadratic formula. Let's write that down. Remember, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Right, so a is 1, that's that coefficient. B is negative 6, that's right here. And c is 1. Right, so we're going to have x equals the opposite of b, so the opposite of negative 6 is positive 6, b squared minus 4ac, all divided by 2. So 6 plus or minus the square root of, that's 4, 36 minus 4 is 32. Then we need to simplify 32. Remember, that's 5 2's. We've done that a lot in class. So I'm going to take out 2 2's and leave a 2. And then we know we can reduce because all 3 of them are divisible by 2. Now that's what x is. And that's all it asks me for, is what is the number. But I do want you to notice that that's 2 different numbers. We have x equals 3 plus 2 square roots of 2 and x equals 3 minus 2 square roots of 2. So we really have found just the number. That's all it asked us for is x. And of course its reciprocal would just be 1 over that. Let's look at our last example. 3 times the square of a number is 6 more than twice the number. What is the number? Well, the good news is we're just looking for x, right? The number is x. Now what do we have to do with that? 3 times, well, I know what that means, right? Multiply by 3. The square of a number. Well, okay, so 3 times not just the number, but the square of a number, which means I have to square my x, is, right, that's the equal to, 6 more than, remember that's 6 plus twice the number. Twice means, you got it, 2 times, 2x. So again, that's a quadratic. I'm going to set it equal to 0. I'm going to move both of these to the other side, so that becomes minus 2x and minus 6. And does that factor? I don't think so. So let's use that quadratic formula again, and let's identify our a and our b and our c. Don't forget the signs. That's b, that's c. So I have x equals the opposite of b. If b was negative, then that becomes positive, and vice versa. B squared minus 4 times a times c, all divided by 2a. So This is a little bit more complex. I've got two negatives, so I know I need to add. So I'm going to have 4 plus 4 times 3 is 12 times 6 is 72. Right, then can I break apart 76? I think 76, if I factor that out, that's 2 times 2 times 19. 2 times 38, I believe. So I can take out a 2. Leave my 19 over 6. And then I'm going to see, can I reduce? Yes, all three of those are divisible by 2. So 2 goes into 2 one time. Right? Don't leave out that 1. You could leave out this 1 because it's being multiplied, but I'm going to just put it in just to be on the safe side, over 3. And since it just asked, what is the number, which is x, I have solved for that, and I am done, but keep in mind I have 2 answers because of that plus or minus sign. You're now ready to do the first half of the application problems.